Hello everyone, good morning, good evening, good afternoon. Assalamu alaikum wa rahmatullah. Depends on from where you are joining. I know we have students from US, from Morocco, from Dubai, and from India. Welcome to Big Bang Data Science Solution, the Ramadan program. It's a free program in exchange for $150 donation to any family in need, any church, any mosque, any masjid. And now we are in week number 5, I believe. So in week number 1, it was a lecture on why we should learn data science. Why do I need to worry about it? Why do I need to invest to learn it? Then we had a session on we learned about the crisp DM, and we in week number 2 we talked about the first phase, and that is business understanding. Then we moved into week number 3, where we had an introduction to basic. It's a crash course on Python. Then in week number 4, we learned about data understanding. And in week number 5, it's data preparation. So we are going to continue from where we got left the last week. So we will continue working on the codes. We'll be using Python, and we will be learning how to dig deep into this data, try to understand the data first before we proceed on what to fix. So that is the plan for this week, and please be a reminder that we have a session tomorrow also. Hopefully by tomorrow we should be able to finish data preparation so we can move into machine learning. That is very important. Okay, dokie. So let's take a look into what we have in terms of presentation. Let's do a recap first, then we'll take it from there. So you are still, or you've been hired as data scientist, and you are working for an auto insurance. And this auto insurance, they are struggling with losing too much money because of the fraudulent. And they hired an expert, which is you, to help fix the problem. So this is the problem they've been struggled with. And the problem says, instead of having a fraud investigation team that investigates up to 30% of the all claims made, we are still losing too much money due to fraudulent claims. So they have a team. They have a team in place that investigates randomly 30%. I don't know how many claims they receive every day. That is probably a question that we need to ask the business. And is this investigation, is it daily, is it weekly, is it monthly? Do they wait for enough claims before they start the investigation, or are they investigating in the daily basis? That is some of the questions that you as data scientists in general, and not only related to this project, but all the projects. So data science starts with questions. Data science starts with questions. So we need to frame them. We learned how to frame this problem statement, how to extract questions, how a bank of questions, so we could build, or we could ask the business to provide us with the questions. Probably that would be our start. So we need to start asking questions related to the business, and of course, to start designing or building an optimal bank of questions, we have to have a team. That is very important. And as a matter of fact, I am working on a project as we speak, It's a paid project, and I'm struggling. I'm really struggling. Literally, I'm struggling. Not because I don't know what to do or how to do it. It's nothing to do with that. It's because I have to do it on my own. There is no team in there. If you got stuck with the question, then you got to ask. I mean, if you are concerned about the data or anything else, data or the business side, from the data side or the business side, it's going to take a while before you get your answer done. So I request or I recommend from you guys, when you are working on a project like this, you got to build your team first. That is very important. And not any team is a team with experts. And within that team, you have to have someone who knows the data better than you and someone who has some knowledge about the business. That is very important. So we got the problem, and we need to design this problem, transform this problem into a bank of questions. It could be one question, it could be 300 questions. And those questions, should be very interesting questions, and questions that can lead to understand the problem, understand the issue, visualize the issue, and also helps to remedy or find a solution to the problem. These questions, they should address that concern, not any question. So they have to be interesting questions. So, and after that, then you need to learn the as a state, to be state, the success of transition, the unit, entity or unit of analysis, the target variable, and how you would evaluate your solution. That is very important. And simply, then we talked about the CRISP-DM. CRISP-DM is a methodology that it's known to be the best methodologies used in analytics. Of course, there are other methodologies. If the business that you're working for has adopted one methodology, you could definitely fit that methodology into analytics. But nevertheless, CRISP-DM is the best so far. As far as I know, there might be other methodologies that I'm not aware of. So these methodologies, or this CRISP-DM that are planning to do, is phased. So we got phase one, then deal with it, then phase two, phase three, phase four, all the way to the end. In phase one, it is critical. It is very, very critical and very important. Very critical and very important. So in phase number one, we need to determine the objectives. What are we trying to solve? What are we trying to do? What is in the business mind that they hired us for? And in the project that I'm working on, again, unfortunately, I'm not allowed to share anything about it. Otherwise, I don't have any problem doing that. The business asks for one objective. The business wants to predict who most likely to leave. And guess what? As data scientist, that is your responsibility also, is to be creative, to go beyond what is expected from you. So of course I did predicted who most likely to leave. I know my model found 6 employees to leave. Number one, before I predicted who most likely to leave, I predicted if we are going to have some leaves in the future. So we predicted what's going to happen the next 3 months, April, May, and June. And guess what? My model predicted that at least six people would live in the next 3 months. So I got a number, and now we know that someone is leaving. So now we need to predict who. And that is the business needs. So I predicted who most likely to leave, and guess what? The second model, the first model, I used time series. The second model, I used the classification with binary. Yes or no. Who is going to live? They are going to live, yes or no. And guess what? The model has predicted 6 employees to churn or to leave. So I took those 6. I know they are going to leave, but can you tell me why? Why they are leaving? Is because they'll be retired, they'll be fired, they'll be resigned, they'll be terminated. What would be the reason? And I predicted the category or the reason of their prediction of their separation. And now, can you tell me when? I know it's 3 months. Can you tell me when? Is it 1 month and 5 days? Is it 3 months and 20 minutes? Can you tell me that? And I was able to predict when also. So the business wants to know if who is leaving. I went beyond that. I predicted how many how many they are living, who, why, and when. And that is your job as data scientist. It's an easy task if you have the right skills and if you have the right team. Right team without right skills is not going to work. Right skills without right team is not going to work. So you have to have the skills and you have to have a team. Okay, then we take the problem. You need to frame it. You need to extract those a bank of interesting questions. Then you need to know how the business would determine your success. Then you need to identify target variables or target variables. Target variable without S means one, or variables, it could be more than a target that you're trying to address all at the same time. So in the first project that I completed, in the first phase or in the first part of the project, I use time series to predict how many leaves or how many separations. Then I use classification binary, which we are going to learn in program, to predict who. Then I used classification not binary, it's multi-class, to predict why. Then I used regression, multiple linear regression, to predict how long will it take them to churn. And luckily, in this program, we are going to learn classification binary. Unfortunately, we wouldn't have time to learn everything. But whatever I'm sharing with you is exactly what I've been using for this project, with plus and minus. So then we need to identify analytic approach. That is very important. I thought about the problem and I said, we are going to do time series analysis. We are going to do regression. We are going to do classification. I know it just by looking into the problem, by looking into the data. The business does not know about these approaches. You know them, and you have to go beyond limits to figure out how you would satisfy, how you would meet the business requirement. Identify the deployment. Are we deploying this model into production? If yes, then we have to increase our team members. We have to bring more members with some skills and development in architecture and development. Then we have a project plan. We got start date, end date. We have team and stakeholders, etc. And guess what? I know what I was doing. I am familiar with the problem. I was very quick, very quick in designing a solution. And now it's time to present. So I did presentation. The business was very happy. But there is something that does not click. Number one is the presentation was not designed for stakeholders. The business, the presentation was designed for the management and some other management with an IT background. Stakeholders, they don't have an IT background. So most of them, but let's assume they are ignorant. They don't know what is decision tree, what is accuracy, what is data science. They have no clue. All what they are expecting from you, give me a number that I can use to make a better decision. So I had to redesign or revisit my presentation 6 times before we come up with. I have now two versions. One version is designed for technical guys like my team, my management, and his low level managers. And one presentation is designed is purely English. No, even you cannot use. We were not. I was not allowed to use the word accuracy. It has to be transformed into probability. So just give them what they are looking for in a very crystal pure English and without any jargon, any technology, in IT terminologies, or any lingo, big lingo that would simply keep them puzzled. Just give them straightforward information. That is very important, and that is why you need to establish, a strong relationship with stakeholders. So we are done with business understanding. Everything is good to go now. And the second phase is please give me the data. The data, we have the data. Then we are going to spend time understanding this data. And this is another critical phase. The business understanding phase is critical is because if you misunderstood the problem, most likely you are going to be designing a wrong solution. Okay, so explore data analysis. You need to visualize your data. You need to apply some statistical analysis to help you understand the data better. And this is very, very critical. And even with an experienced, skilled person like me, I was doing some stupid mistakes. And talking about this project that I worked, I'm still working on. I have the data, and the business or the stakeholders, they have the data in terms of dashboard. I have one column. It does have a number of employees who left from 2019 to 2021 to 2022. So you've got 12 months of 2019, 12 months of 2018, 12 months of 2020, 12 months of 2021, and 3 months of 2022. So in terms of how many churns that we have every year, my numbers are inconsistent with the numbers of the business. I got 5 in 2022, they have 5. I got 7 in 2021, they got 7. I got 14 in 2020, they got 14. But in terms of months, we are off. So I got, for example, in 2022, I got 3 in March, they got 1. I got 2 in April and February, they got 2. And they got 1, and they got 2. So in total, we got 5. But in terms of months, we are off. And so the business asked, "Can you please check what happened in March?" In March, I am off by 1, and that's it. You're done. So you need to redo. Just because you are off with 1, the business, that's it. Yeah. They are not going to believe whatever you designed, or whatever they won't believe the output. So you got to redo. And what I learned from this exercise is you got, as data scientists, you have to keep checking your output. Check the numbers that you are using. Make sure it's consistent with the numbers given in the data. Sometimes when you do, for example, in Python, you merge 2 files, file A and file B. And sometimes instead of doing the merging using the right, using the right merge, you are supposed to use the left and accidentally use the right. And of course, left and right, they're still going to merge, but the outcome is going to be different. So check the numbers and to make sure they are consistent with the original data set. And that is very important. So anyway, you are going to spend time exploring your data, visualizing your data, and analyzing applying some statistical analysis. And now we are going to have a roadmap of what needs to be fixed. So taking that, and now we have a lot of work to do to fix our data and to improve its quality, to make it ready to go, make it better, a better version that we can use to proceed with our preparation. And in the preparation, we are going to learn all these, few of these techniques. And finally, we are going to have a better version. So after we handle duplicates, missing values, outliers, after we handle categorical data through normalization, and transformation through normalization, factorization, binarization, standardization, and binning and decomposition, if you were to use time series. Now, then feature selection and feature engineering. Now we have version number 4, and this is the version we are going to use for our piece of cake. This modeling is really a piece of cake if you were to do the 3 first phases correctly. If you miss something, if you misuse something out of the first 3 phases, no, I really don't care what models you are using, because you are off. Okay, that is very important. And the 3 first phases is more than probably between 70% to 80% of your entire time. 70% to 80% should be spent in the first 3 phases, understanding the problem correctly, understanding your data correctly, and pre-processing your data correctly. So let me stop here, and I'm going to open the floor for you guys to see if you have any question, any concern, any doubt. Please speak out. Questions, concerns, please?
I'm good, Mo.
Okay, folks.
What is the raw data?
Raw data is the data that you were given at the beginning. It's called raw. It has not been prepared yet. That's called raw data. Raw data could be a good data. You don't need to do anything about it. That is going to be straight raw data, then straight to the model. You don't have to prepare it. Raw data could be or dirty data. You have to dive deep into it to fix its quality problems, inconsistency, duplicates, missing values, outliers. Name the problems and get it into a better version number 2 or 3 or 4.
Always give a raw data or no? Sometimes they were good data.
Whatever data you are given, and regardless of how good or bad it is, it's called the raw data. Yeah, you will be given, it's called raw data because you don't know what is in it yet. So once you investigate your data, trying to analyze it, trying to understand it, it could be that raw data is good to go. Now it's not raw data anymore. Okay. So we got the data here, and this is our data we will be using. And
yeah, brother, I have like one question. Sorry.
Yes, sir.
Okay, so the question I was having is for a project, when a a scientist is trying to understand about the data and they are doing like the first analysis of the data, do you use any templates or anything? Because that's like a repetitive task, right, in every project. Or do you have to write all the analysis from scratch every time?
No, it's the same. Once no, it's a template, and I'll give you the template. Yeah, I will give you the template, but again, that template could be good to go. It could be improved because if it works for one particular data set, that does not mean it's going to work for the next data set. If it works for one project, that does not mean it's going to work for the next the future project. Okay,
Okay.
and and also for the modeling, there is one concept in data science is called no freelance no freelance theorem. No freelance theorem. So what is this no freelance theorem? It simply means that that if you have there is not good model for all cases. So for example, if we build a model today for this business problem, and we find out like classification and random forest is the best model, that does not mean random forest is the best algorithm. That does not mean the random forest it is going to be our model to use for next time. Please remember that no freelance theorem means the project, there is no one single project, a good project for all, one single algorithm or one single analytical solution for all your business problems. It varies, depends on the scenarios, depends on the problems, depends on the data given to you. And even a few differences in terms of the data could change one model to a different model. Okay, folks, so we got the data. We got the data here. Yeah, as data scientists, always good to scan over this. Just scan, the first scan. You don't have to do anything yet. And so what do we have? Of course, we got some date. That is very important. We got some dates in there. We got some categorical data in there. Yeah, we got some categorical data in there. It's numbers, as you see, it's numbers, but there is the slash makes it categorical. Yeah, we got categorical data in there. We got categorical data. We got some large values and small values, the zeros. That's something that you really need to investigate. Why do we have zeros in there? Just looking into this, and okay, going through, we got some negative values. You might raise your attention. You got some question marks. What is this question marks? Is it a missing value? Is it, what is it? And yeah, we got categorical data, we got numeric data, we got categorical data, we got question marks again. Okay, we got combination of numeric and categorical data, and we got a target variable. This is very important, and we talked about target variable the other day. We talked about target variable. So we know now what is needed from us. So simply because we have a target variable, I know that the best or the optimal analytical approach would be a combination of descriptive analytics and predictive analytics. And in predictive analytics, we are going to be using classification because the target variable that we have is a binary. So this is what we have in the data. And in terms of the content of the data, we got the data on the clients. We got the data on the policies, policy. We got the data on client again, education level, insured occupation, hobbies, relationship. It's all clients. So we got the data on the policies again. Yeah, no, this is incident. Yeah, we got the data on the incident. It's all incident. Yeah, incident. It's all incident. And we got the data about the cars, and so we got probably the data collected from different resources. It's not only one resource, as you can tell. It's not. It's one. It's multiple resources. So simply a very simple scan that you could use. You could do just to give you a hint of what to expect in the data. Okay, and now we are gonna open up the Jupyter notebook. We'll be doing understanding data, and okay, go to batch number. Data science journey. We are going to do program codes. We are going to do Python, and I believe we were in data preparation probably. There we go. Okay, so a few things that you should be aware of is not all given features are needed for analytics. Yeah, few things that you could, or few type of the data that you could eliminate right on the fly. So number one, we could eliminate all IDs. All IDs. Unlike time series. Here we go. Got to eliminate all IDs. Like what? Like customer ID, student ID, transaction ID, any IDs. Why do we think we should eliminate these IDs? Any thought? Any thought? Why do we need to eliminate IDs? Simply because they are random.
We don't need that information for our analysis.
No, sometimes we do, but they are random numbers, random values. There is no difference. Like for example, we have here a policy number. Okay, we have policy number. Let me make this. Yeah, we got policy number as you see. Okay. What is difference? What is 521, 585 is going to add to analysis? Nothing. So it's just a number, just a random number. It's not a characteristic of a behavior. It's simply a number. So we are going to eliminate all these random numbers. We don't really care about them. Sometimes, yes, we are going to need them, especially if you are working on, let's say, an intrusion detection problem. Then you are going to need, in that case, we are going to need PC ID, PC, IP, etc. You are going to need a specific information about some cases. But apart from that, all these IDs, just eliminate them right on the fly. Number one. Number two, we are going to eliminate too much personal information. For example, I really don't care about your name. I don't need the names. If you have a column says Mohamed Wani, Azam, Afifa, Corina, Gul, I don't care about that. Now, why do I need to have a names? Just take them out. So names, phone numbers. We don't care about them. Email addresses. So all too much personal. I don't care about you, who you are. I care about, for my analysis, I really don't care about who you are. I care about what characteristic that you have. I need your characteristic, your behavior, not something that everyone has. Name. Okay, that is very important. We are going to eliminate names. Number 3, this is right on the fly, right before you read your data to whatever tools you are planning to use. Probably scan and see, eliminate something like this. Then we are going to eliminate constant values. For example, if you have age and all is equal 33, for example, you have one column. Now, for example, you have one column called age, and we got 33, for example. So you got 33, everybody is 33. Then eliminate. It's constant. There is no change in there. Okay, if you have a state that it says Tennessee for everybody, just remove it. You have a department that is called networking or whatever you call it, or marketing. The department is called marketing. For every 1 million, 2 million records that you have, just eliminate it. It's constant. It does not change. It's not going to add value. If it's changing, then we keep it. If it's not, just eliminate. So constant values, just remove. Then also we are going to remove anything that is high cardinals or high cardinal. For example, you have zip codes, and if you want to search how many zip codes that we have in US, number, I think it's 38 something number of zip codes in US. It's around 41,000 records. Imagine that you have a column that is called zip code. Yeah, 41,000. The levels that you have to deal with. So what we could do, and if you have a zip code and you have another column called state, or cities or states or counties or regions, all geo or spatial data, then we are going to keep only one of them. So of course we are not if you have only zip codes, then we need to transfer it into states probably, or states or cities or something else. If you have zip codes, you have states, you have cities, you have counties, you have regions, then just pick one of them, eliminate the others. I mean, it's the same information. If I'm telling you I live in Atlanta, it's the same information probably if I was to tell you I live in Georgia, of course with some level of granularity. So high cardinals or high hierarchical, just eliminate that. Number 5, we are going to eliminate information that is dates, unless you are planning to use time series analysis. Okay, time series analysis, then you are good. You keep the date. Otherwise, just take out the date. And of course, there are other, I think there are 6 one, I can remember it. So all IDs, too much information, constant values, high cardinal, and dates. Yeah, this should be enough. Okay, and yes, that should be enough. So let's take a look into our data. And I want you guys to help me I want you guys to help me figure out what to remove and why. Okay, and what to remove and why. Let's do that together. We got month as a customer, yes or no? I need
We
some.
need.
So we are gonna keep.
Yes.
We are gonna keep number, policy number. We need to remove, right?
Yes.
Simply a constant, simply a constant value. Nothing in there. Yeah, policy bin date remove because we are not doing time series at this point.
Yes.
Policy state, policy deductible, policy annual premium, umbrella limit, insured zip, and we got state, we got zip. So which one we want to keep? So we are going to keep state. So we are going to,
We can keep the zip.
yes, ma'am.
We can keep the zip.
Okay. And we got insured education level, insured occupation, insured hobbies, insured relationship, capital gains, loss, incident date. Just remove.
Yeah, we need.
We
Oh, okay.
need. We could use it if we were to use time series, but now we are not doing time series.
Okay.
Incident type, collision type, incident severity, incident contact, incident state, incident city, incident location. We got three piece of information with different. They are the same piece of information, but the difference is the level of details or the level of granularity. So which one?
I think since we are keeping the zip, we can keep the just incident location. That would help.
So,
We're not keeping the zip, we're keeping the state. So I would keep the city in this case.
but please, this the zip is the state policy state, and the zip of policy state. And now we are talking about different location. This is incident state, not policy state. So we are,
Oh, so
yeah.
okay.
We keep the zip code here.
No, we really don't. We are going to remove the city and we are going to remove the incident. And of course, you always can come back and switch. Okay, and we got incident hour of the day, number involved, damage, body. Everything looks so far so good. Okay, so we got, yeah, we got 39 features, and now we are removing 1, 2, 3, 4, 5, 6. Yeah, 6 features. So imagine how much space you are going to save and how much memory in memory and how much in terms of speed that you are going to save. So if you have, let's say you have 10 million records and you got 100 columns, and out of the 100 columns, 50 columns you cannot use them. There is no need. So if you were to eliminate them before you read your data, then of course you are going to save space, you are going to speed up the process, and you are going to save space in the memory. So this process is called knowledge, prior knowledge. Elimination using prior knowledge. Okay, are there other processes? Yes. And if we have time, we are going to go over them. So we have data, and of course we are going to eliminate. It's called dimensionality reduction. So we are going to reduce the dimensionality, and there are two methods. One is called feature selections. Feature selections, we are going to select what to keep and what not to keep. We are selecting what to include and what not to include. So nothing is involved in there, simply using your knowledge. So feature selections, we could use your prior knowledge, and we could use correlation analysis. Correlation analysis. Okay, or this is feature selection. There is another method is called feature engineering, and we are going to use either non-machine learning method, or we'll be using machine learning method. So prior knowledge, remove 1, 2, 3 that we covered. Correlation analysis, we'll be doing who's most likely. We are going to keep high correlated features with the target variable. Feature engineering, non-machine learning, we could do aggregation, we could do binning, we could do ratio, we could do so many things. Machine learning, we could do PCA, we could do LDA, principal component analysis, linear discriminant analysis, we could do kernelized PCA, we could do discriminant LDA, linear discriminant analysis. We could do many things. So we have raw data, and now we should, if you apply one of these, we are going to have version 2. Okay, are you guys clear about the process?
Yes.
Any questions, any concerns, any doubt, please?
Could you repeat again? What does meaning each of them, please? Diagram.
Okay. So you got a row in our case, we got 1,000 records, and we got 39 features. Okay, and we are going to use a method called dimensionality. Let me see if I can type. Here we go. We are going to use dimensionality reduction. Here we go. And with this dimensionality reduction, there are two methods: feature selections okay, and we got another one is called features engineering feature engineering. Okay, and under feature engineering, feature selections, we got no machine learning, and we got machine learning, and we got no machine learning, and we got machine learning, and I will talk about this shortly.
So prior knowledge is no machine learning?
Yeah, just give me a second, I'll explain that. Okay, so this is the plan. We got dimensionality reduction. We got either we are using feature selection or using feature engineering. It's called also feature creation. It's called also feature extraction. And under feature selections, we have non-machine learning method, and we have a machine learning method. Let's put this consistent so we can have a graph. And under feature engineering, we got non-machine learning, and we got machine learning. Okay. So under feature dimensionality reduction, we started with 39. We are doing feature selections. No, non-machine learning. We did not. Did we use any machine learning technique to figure out this? Yes or no?
No.
So there is no machine learning. Simply our knowledge. So prior knowledge is non-machine learning. So we are going to use prior knowledge. And guess what? We reduced from 39 to what? 33. Yeah, 33 now. So then all these 33, we are going to use correlation analysis to reduce it further down. And once we reduce it, and of course we still have, so let's say that we are going to use correlation analysis, and we find out 19 are good to go. But this 19, we still have categorical data. So we are going to do transformation, and once we transform, it is going to be 300 features. So we started with 39. We did 39. We did feature selections, and now we have 33. And with 33, we are still gonna further resize them, downsize them by applying correlation. Correlation analysis is a scientific method. It might not be machine learning, but it's a scientific method. Then we are going to do correlation analysis. Then we reduce that to 19. But in this 19, we still have categorical data that we need to transform. So once we transform it, it's gonna the number is gonna grow. Now we got 300. So we got 39, 33, 19. Now we got 300. This is good to go, but it's too much info, too much dimensions. So we might need to use either aggregation. In aggregation, we are going to do binning. We are going to do mapping. We could do ratio. We could do flagging. There are other techniques. Or we could do machine learning. We could do PCA. We could do LDA. We could do kernelized PCA. We could do also QDA, quadratic discriminant analysis. We could do many other techniques. But this is the flow that you could use to reduce the dimensionality of your data. Questions, concerns?
Good move.
Shamsul, I know you asked the question. Are you clear, brother?
Yes.
Good. Okay, good. So let's go. Let's go now to Python. Yeah. So we are going to read the data. We are going to import packages. And if you don't know how to import packages, so you please go through the crash course. It's available online. So we are going to import the libraries, number one. Then we are going to maximize the number of columns to see. Then we are going to read. We are going to create a variable called our insurance. We are going to read our data. So, and now we are going to start with basic methods like a head that provides the first 5 elements of your data. The shape will provide you how many. We got 27. No, it's 39. So it should be. I'm using Let me see. I need to change. I need to change the data. So I'm going to give this data. Hopefully it's going to pick it up. Okay, let's cross the fingers. No, it says no file, such file. Okay, so what is the name of the file? So I believe the name of the file, yes, it's different name. So you see, this is version 2. That's why we have less features. Okay, here we go. So now let's take a look into the dimensionality. We should see 39 features, 1000. We learned about the info. It does provide you how many categorical data that you have. So the moment you see objects, you know you have work to do. So we got no missing values, which is good. And we learned about the describe function that provides statistical analysis. Again, when we are talking about statistical analysis, this is what we are looking for. And of course, it depends on what's going on this file. It depends on the type of the data that you have. Can you? Let's do this. Okay, so, and you should know this, otherwise you need to go through some of the recordings. So we got the data, and number one, we need to know the type of the data, and it could be either categorical or numerical. Either categorical or numerical. And in categorical, we have a nominal and we have ordinal. And in numeric, we have interval and we got ratio. Okay, so when we apply statistics, the output of statistical analysis is different. So for categorical data, we are going to get the mode, we are going to get frequency. And we got the count also.
No, I just want to add something here. I think we will need to change the categorical data into new numbers.
Not yet.
Okay, it's not there. We are not there yet. Okay, gotcha.
Now we're still in the process of understanding the data. We are here. No, you're talking about this one.
Okay.
That is too advanced for now. Now we are still in understanding data. Yes, you're right, but it's too early. So we are going to do count. And for numerical data, we are going to get the 5 numbers of John Turkey, and I believe we talked about this in one of the presentations. John Turkey, and he's the father of the 5-number summary. John, here we go. John Turkey. This is the guy, and he's the father of the 5-6. It's called the 5-number summary. 5 numbers summary. John Turkey explored the data analysis. Please go through that and educate yourself. It's really good and good to know. Good to have this knowledge. At least it's going to help you speak fluent at the interview. There we go. So let's search for 5 numbers. 5. So I don't think it is searchable. Yeah, it's not searchable. That's why I couldn't find. So this is a scan, Explore Data Analysis. So it's a good book. I never had a chance to look into it, but it's a really a good book. It has all the information you are going to need. All information you are going to need on statistical analysis. It does provide you all the information you need. Anyhow, so for this analysis, we are going to have the mean, median, and we are going to have the 25%, the first quartile, we got the 50%, and we got the 75%, and we got the max. So you got 1, 2, 3, 4, and 5. This goes to 1. I'm sorry, yes, because we have it's 5. So when we apply this describe, it is going to provide by default. It only is going to provide you the information on the numerical features. It does ignore the categorical features. So as you see here, there is nothing about the no information about the categorical features. And what do we have? Age, for example, we have the minimum is 19. Does it sound right statistically? You need to figure that out. We got 25%, we got 30, between 19 and 32, it's below 25%. 38, it's the mean. So we got 19 and 64. So 38 is the average or the mean. Now 44, from 38. 44 from 38, 34, 44, it's in the second third quartile, and we got the max in there. So we got some information. Now we start understanding the data. And the other day we talked about the transforming or transposing this information, just simply changing the layout. So if you were to do describe, and now describe dot transpose, it is going to describe it, the same information, but for the first one, we got the month, or we got the features as the columns, and we got the statistical analysis or the statistical information as the rows. And for this one, we got the rows versus the columns. It's the same information, but different layout. As I said, the describe provides the statistical summary of your numerical variables. And if you were to do the non-numeric, and this is what we have in the data, we got it is going to provide you information on the integer and the float, but it's not going to provide information on the objects. So we are going to tell it, hey, please go ahead and include only objects or booleans or character. So, and we don't have a booleans, we don't have a character, but it's going to provide information on the objects. And this is what we have. We have the count, we have unique, we have the top of, they have the frequency. So this is the information we are going to get for categorical data versus information we are going to get for numerical data. Both of them, at least now we are start understanding what we have in the data. We are still trying to understand what we have in the data. Okay, and let's take a look into the target variable. Now we have to take a look into the target variable to see what we have. So we got a target variable in there. Okay, and it's color green because this is our baby. This is the animal that we are trying to investigate. Let's take a look. We are going to use the value counts. It is going to give you a percentage, or then it's going to give you the number of levels. So we got 0, 750, 753. 0 means in this column, 0 stands for it's not a fraudulent, it's a legitimate claim, and 1 stands for it's a fraudulent. So we got ones and zeros. So how many ones that we have and how many zeros that we have? We got 753 zeros out of 1,000 that we have. So we got 1,000 claims that we learned that from the shape method. We got 1,000 claims. Out of this 1,000 claims, and this is it's called historical data. It's already happened few months, many years ago. So out of all the claims that the business has approved in the past or has dealt with in the past, 753, they were legitimate. We were good. We did not lose any money. And we lost money on 247 claims. They were fraudulent, but we approved them, or I don't know what happened, but they were 47. So this dot value count, we are going to add into it one parameter is called normalized equal true, and it's going to transform these numbers, values here, into a percentage. So we got, what happened? Yes. We got now 75% and 25%. And of course, we are going to visualize it. And this is what we have. This is what we have in the data, in historical data. This is a fact. So in your presentation, you could include this. In your presentation, you are going to tell the business, we are going to tell them we have 1,000 features. And out of that, we got one ID, we got 4 or 5 categorical data, and we got a target variable, and the remaining is numerical data. Then you talk about the statistical analysis, find out if there is anything out there that stood out, does not make sense. For example, and I believe I asked you this question in the past. If in the age, we got, for example, the minimum is 11. Of course, you need to raise a flag. You need to question the 11. And there is nothing wrong with 11. Nothing. You could have a 0 in there. You could have 300 in there. Nothing wrong with it. From the, talking about the value perspective. But when we are connecting this age to the domain, of course, this now won't make sense anymore, because I don't believe that there is any our insurance company that assures 11 years old drivers. So there must be a typo in there or an error that we need to investigate. So these numbers, you should when you are trying to interpret these numbers, you need to connect them with the domain that you are trying to analyze. They could be the right numbers, nothing wrong with them, but when you link them to the domain, they don't make sense anymore. You have to raise a flag, and nothing you can do except you need to go to your team and explain, get your doubt cleared. Any questions, concerns, please? Any questions? Okay, folks, so then we are going to move. Now we have enough information. And now we are going to move into, I think, the other, let me bring another file, pre-processing. Data understanding. Here we go. I think this is the file that we used the other day. So we did everything. Now we moved into data visualization. Okay, so we looked into the numerical variables. So what we are looking for, we are looking for specific things in our data. The best data that you could use for analysis is the data that is normally distributed. Most of the algorithms require as an assumption that your data is normally distributed. So this one is not. Okay, this one is very bad. Now we got 2 animals in there. They are outliers. And we also learned about the bar plots, comparing the incident state to the incident policies. And this is an insight that we got. We got we got 3 states only. We got Ohio, Indiana, Illinois, 3 states. But when it comes to reporting states, or the states that you or this insurer had accident, they are out of state. So except the Ohio with few incidents, we got 1, 2, 3, 4, 5, 6 more states. So this is simply an indicator that there is something wrong with the policy. I don't know what the business is doing, but the policy has to be changed. We are going to change the policy based on what this data. Yeah, probably, I don't know, is because we have a sample data. We have only 3 states. I don't know what's going to happen if we were to bring the population from all the 50 US states. That could change. But based on this given data, it could be that this company only operates in Ohio in 3 states. But regardless, there is an insight in there. We have 3 states that ensures these policies, but we have a lot of calls from the out of state. So we must add one element, something in the policies that trigger this. It could be a question that asking you how far you'll be traveling, and based on that, we can change the premium. And of course, if you call us outside what you specified in your and you are going to say it, if you tell me how far you are traveling every day, you say 50%, 50 miles, that's fine. But we are going to make it clear to you that if you are traveling, if you are calling us out of this 50 miles of accident, you are going to have a problem. So we are going to enforce you to tell the truth. Tell me from the beginning how many miles you'll be traveling. If it's 100, that's 100. Of course, the premium is going to change, but it's better than to change the premium rather than calling us from a different state and you are not going to be covered. So we are going to generate more revenue for changing simple few things in the policies, and also we are going to avoid a lot of accidents claims. So that is one way of saving the business money without even doing any prediction. Yeah. So the one way we are going to save a lot of money because of the fraudulent. Very simple. Just all what we did here is descriptive analytics. We have not done anything fancy yet about predicting who most likely to call with fraudulent claims. We simply went to the data given to us and explore what we have. Okay, and there are a lot of, and also we did male and female, and the other day we talked about we cannot discriminate, we cannot use features that would create some legal issues for the business. You need to be careful, and you need to bring into your team someone who is good, who understands the legal part of the game. Otherwise, you never know what would happen. If you were to make a decision in a human based on some discriminating features, you might end up being behind the bars. You might end up paying a lot of money. Someone might sue you. Someone, especially if they feel that you are discriminating against them, they might sue you, and they are going to win the case. Surely they are going to win the case. So then we did multivariate, and now we are going to do this is all data visualization to help us understand what we have in data. And now we are going to learn about something very specific. It's called correlation analysis. In the correlation analysis, please pay attention, and we are going to stop here. In the correlation analysis, what we are trying to determine relationships between our features. And we have two types of features in this data set. We have two types of features. We have features that we are going to use to make prediction, and we have a prediction, we have a label. So we have predictions, features used for predictions or predictors. They are called predictors. And we got label. Okay, we got predictors and we got label. These predictors, they are called X. They are also called independent variables. They are also called inputs. They have many names, but they are called inputs. Label is called target Y. It's called target variable. It's called class. It's called outcome. And it's called also a dependent variable. Any question, concerns so far, please?
No, I'm good.
Okay, others? Are you all good?
I missed the last one, the DV. What was that?
Dependent variables. So
Thank
this
you.
one is called independent variable. I repeat, it's called X, capital X. Independent variables, inputs. It's called, this one is called lowercase y. It's called target variable. It's called the class. It's called outcome. Sorry guys, I cannot type using the mouse. It's called dependent variable, and it's called also output. Okay, that is very important. And now we want to find the correlation between these two, the correlation between predictors and labels. The correlation analysis is always going to be in a range between -1 and 1. So always going to be between -1 and 1. Okay, in other words, the relationship between incident hour of the day and the fraud, is going to be between -1 and 1. Policy report available and target variable is going to be between -1 and 1. The correlation values between all these variables and the target variable, and between these variables and themselves, is going to be between -1 and 1. Okay.
So we would have 33 of those, like 33 features correlated with the target variable?
Yes, we got -1 and 1. And what do we have between -1 and 1?
0.
We got a 0. If the value of the correlation is above 0, it's called positive correlation. If the value of the correlation below 0, it's called what?
Negative.
Negative correlation.
Negative.
If the value is equal 0,
No correlation.
neutral. Okay? There are two, either above 0 or below 0 or equal to 0. And what we are trying to find, we are trying to find the correlation between x and y. And also we want to find the correlation between x and other x. x1 and x2, for example, x3 and x4, x5 and x7. So how many x's do we have in total?
1,000.
No, sir.
Okay.
How many x's?
33.
32. One should be the dependent variable.
No, I'm talking about the raw data. How many? What is the dimensionality of our raw data?
39.
39.
No, I'm talking about dimensionality. You got 1,000 by
39.
39. Out of this 39, how many x's do we have?
33.
No, ma'am. Out of this 39, how many target
38.
variables do we have?
38.
So we got 38
Target should be
x's, and of course we got 1
on Y.
and y. So 38 plus 1 is 39. Okay, so we are going to do 38. Of course, now we are going to remove, no, if we were to remove this 6, then we are going to have only, let's assume that we removed the prior knowledge, and we removed the 6, so we got 33. Okay, we got 33 now. So now, how many x's do we have?
32.
32, and we got 1. So we are going to do 32 correlation between x and y, and 32 correlation between x and x. So for the correlation between x and y, which one do you think we are going to keep? Which values? Is it below or equal or above 0?
Above.
Above.
Why? So the answer is, we are going to keep below 0 and above 0. We are going to keep positive correlation and negative correlation, but we are going to remove anything that is equal 0. Why anything is equal 0? Is there is no correlation, there is no chemistry. There is no
Between those variables. Yeah.
between x and y. So why do I need to keep you? If you are not going to provide me enough prediction, why do I need to keep you? So
That's correct.
yeah, for the correlation between x and y, we are going to keep anything except if it is equal or closer to 0. You are not going to find 0. You are going to find something very, very small, 0.00035, whatever. Just eliminate those. That is correlation. Please pay attention. Correlation between x and y. Correlation between x and y. We are going to keep everything except equal, except
0.
equal or closer to 0. Okay. And now in terms of correlation between X and X, of course, if I have, for example, two columns, one of them is height, and one of them is shoe size. Of course, if you are high, most likely your shoe size is going to be bigger, right? Larger. So we are not going to keep both of them, because both of these features, they are providing us the same exact information with difference and level granularity. So they are highly correlated. If we were to keep them, they are going to skew up our analysis. So we have to keep only one. So we are not going to keep everything. We are going to keep only one. So the correlation between age and the shoe size is going to be closer, equal, or closer to what? To 1. So when we are talking about the correlation between X and X, we are going to keep the one that equal or closer to 0. That is the correlation between X and X. X and Y, we are going to keep anything that is not 0. X and X, we are going to keep anything that is closer to 0. Anything that is closer to 1 should be eliminated, or closer to -1 should be eliminated. Now let's do the exercise. And by the way, correlation analysis only applies for numerical values. And for correlation analysis, there are 4 conditions. There are 4 conditions. Number 1, we have to have a pairs. Means if you have in one column 1,000, we need to have the second column 1,000. Number 2, they have to be linear. Number 3, they have to be numeric. Number 4, they have to be real. So if it's not numeric, it's not going to be picked up. But let's run it. Okay, we are going to do to use the correlation. We are going to use dot CORR bracket. That is the function. So give me, I'm going to create a variable, and that variable simply is our insurance correlation. Let's run it and let's take a look. Okay. I'm going to make a copy of this screenshot. Okay, and let's bring the last column, which is the correlation of the target variable. Okay, so these are the correlations between all x's and the target variable. So out of this, which one? And remember, the correlation always going to be between -1 and 1. And now we are looking into x and y. So simply we are going to keep anything. We are going to remove anything that is in this area. So out of these features, which one you think should be excluded?
Auto year.
Yeah, our year is very minimum, 0.07. We got 0.17, 1309, 0403. This is another one, incident hours. -1, 0, 19, 0, 0. So, for example, this incident hours is somewhere here. Or this one is somewhere close to the, yeah. So we are going to eliminate these two features. So how many we eliminated using prior knowledge?
Two.
No, prior knowledge.
6.
So we
6 plus 2.
yeah, we started with 1,000 records and 39 features. You guys remember? And we use the prior knowledge. We eliminate the ID, the high cardinal.
Left with 33, and now we are eliminating 2 more.
Okay. Now we are going to do another 2.
Yes.
And so this is correlation between X and Y. How about correlation between X and X? Let's take a look.
Yeah.
So now we are going to do X and X, and we are going to look for big numbers. Let's take a look. Here we go. We got 80, 81, and 98, 72. So we got for X and X, we got some values. They are now we are talking about X and X. X and X, we got some values. They are very somewhere here. And if you are not good with these numbers, now we are going to visualize it. SNS. Let's import. Yeah, we are going to. It's called heat map. Heat map. And this, what does this heat map is doing? It's simply visualizing these numbers. If you are not good, you don't have really. It's hard to find out. Of course, you can customize it to give you exactly the numbers you are looking for. So let's take a look into this, and we are going to end up with this. So this heat map, what it does, so we got colors that is dark and colors that are white, and the scale is normally is between -1, this -1, and this is 1. Okay, so we got here all the features including the target variable, and all the features including the target variable. So the correlation between X and itself always going to be a 1. For example, the correlation between month as a customer and month as a customer is going to be a 1. 1, 1, 1, 1. That's, we have a diagonal now. 1, 1, 1, 1, 1, all the way to the end. Okay, so the correlation between a feature and itself is going to be a 1. Now we got few things here that stood out. We got these animals. We got this. So what do we have here? We got month, total claim. It's highly correlated with total claim. It's highly correlated with injured claim, with policy claim, and with vehicle claim. Injured claim is the same, policy claim, and vehicle claim. So we got 4 type of claims, 3 type of claims, 1, 2, 3. We got 4, and they are highly correlated. What do we think we should do?
We should eliminate those
How
variables that are
how
correlation.
many we should eliminate? 3. Which one that you eliminate? That is a tricky question.
The lowest one.
Lowest one to mean to what? They are all highly correlated, and we'll find out. So also we find out that age, month as a customer, and age, they are highly correlated. So we have to keep one of them. So we are going to eliminate 3 of the claims, and we are going to eliminate 1, either age or month as a customer. Which one to keep and which one to eliminate? That is a tricky question, and the answer is very
I will eliminate age here
why?
because like even though like age it matters to have our insurance, but in this case we
No,
like
no,
based on the numbers as a months as a customer
no,
with the
no,
policy.
no, no. So we let's say that we know the age and customer. What is the name of it? Month as a customer. They are highly correlated. So we need to keep one of them. So which one to keep? The one that we keep is the one that has the highest correlation with the target variable. So we got month as a customer, we got age. Which one has the highest correlation with target variable?
Month.
So we are going to eliminate age.
Yes.
Okay, how about for the claims? We got total claim, injury claim, property claim, vehicle claim. We know they are highly correlated, and we know we are going to keep only one of them. Which one to keep? Then we need to go back and find out which one has the highest correlation with the target variable. So we got 0.16, 0.09, 0.13, 0.17. So we are going to eliminate this. Bye-bye, 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 and we are going to keep this one. So now we got 6 minus 2, minus 1, and minus 3. So 6, that is 10, 12. So 12 features, they are gone. So how did we come up with this number 12? Using the prior knowledge and using the correlation analysis. Any questions, concerns, please?
Okay.
Okay, folks, that's it for today. I'll see you guys tomorrow. Until then, you guys have a great evening, and bye, everybody.
Thank you, Mom.
Thank you.
Bye-bye.